Alright, let's graph this absolute value equation, at least sketch a graph of this, but first I want to make a comparison. I want to compare in words how this graph has changed from the parent function of the graph. Remember, the parent function is the most basic function, so the parent function is just y equals the absolute value of x, the most basic function in the family. That's the graph that, if I just give you a quick sketch of it, has a vertex at 0, 0, it opens upwards, the slope of the sides are 1, and then -1 for the other half of the absolute value graph. So that's the parent function. Let's make a quick comparison. Let me erase some of that stuff. Let's make a quick comparison about how this graph has changed, and then we'll go ahead and create a sketch of it. So here's what I do. I kind of go through and I draw little arrows pointing to what all these numbers do. The number with the x inside the absolute value bars is always your horizontal shift, and it does the opposite of what it says it's going to do. So if you see a +1, rather than move the graph to the right one, it actually does the opposite and moves the graph to the left one. So that's your horizontal shift. It'll move the vertex and all the points to the left one. Next up, we have this number at the end. That number at the end is your vertical shift, and that will move your graph up or down. And it does what it says it's going to do. So a -2 will move the graph down 2 spaces. All your points will be shifted down 2 spaces. Finally, we may have a number in front. And that number in front is just going to tell you basically how steep the sides of the line are. They're going to make the graph either steeper or less steep. And it may flip it if that graph's negative. We're going to use words like stretch, and I like the word compress to graph this. A number bigger than 1 is going to vertically stretch the graph, so it's going to stretch up taller. We're going to sort of use that as our slope number, though, so we'll work with that in a second. So that's sort of my comparison. Let's go ahead and get a quick sketch of this graph. So here's how I begin. I graph my vertex first. My vertex is normally at 0, 0, but remember we've shifted this time. So take that point at 0, 0, move it to the right one, and then move it down 3 spaces. So my new vertex, I'm going to count right or left one, and then 1, 2, 3 down, and there's going to be my new vertex. And let me erase that other point so it's not in the way. From there, I know my graph is going to be narrower, but I want to be a little more accurate. And so I'm going to actually use this 3 in front as a slope number. Keep in mind, since we have an absolute value graph, we'll have half of our graph will be a positive slope, the other half will be a negative slope to make that V or A shape. So from my vertex, I'm going to count up 3 and over 1 since it's a positive 3, and then up 3 and over 1. I suppose that's one thing I could have noted up here. Since my graph had a positive A value, it's going to open upwards. It'll make that V-shaped graph instead of opening downwards and make an A-shaped graph. So I could keep doing that. There's half of my absolute value graph. For the other half, I need to remember that it's just sort of another reflection, and it's going to be a slope of -3 for the other side of the graph. So count up 3 and backwards 1, and up 3 and backwards 1. And there's my sketch. Oops, I missed that point. There's my sketch of the absolute value graph, and I can tell that, yeah, it is a little bit narrower than, or a little bit narrower, or it's been stretched vertically from the parent function. Let's go ahead and do one more, and again, we'll start with that comparison to figure out what each of these numbers is going to do to my graph compared to the parent function. So start with the number inside the absolute value bars. That's your horizontal shift, and remember, it lies to you. It does the opposite of what it says. So a -3 is actually going to move the graph to the right 3 spaces. The vertex and all the points will be moved right 3. The number at the end is your vertical shift, and it does what it says, so everything will be moved up 2 spaces. Finally, we have a couple numbers in front. The 1/2, since it's a number smaller than 1, will actually compress the graph or make it less steep, or you may say it opens wider depending on how you're doing your comparison. And then finally, I'm going to note that negative sign in front is actually going to reflect my graph. The graph will now be opening downwards in this case. So I'll have an A-shaped graph instead of a V-shaped graph. So let's use all that information to make a quick sketch of this. So again, start from 0, 0. That's where the vertex is for the parent function, but then I'm going to move that right 3 and up 2. So 1, 2, 3, up 2. So there's my new vertex right there. Since I've noted that my graph opens downwards, I'm going to use that idea to get my slope. Remember, you're going to have half of your graph will have a positive 1/2, half your graph will have a negative 1/2, and it is opening downwards, so just keep that in mind. So I'm going to count down 1 and forwards 2, and down 1 and forwards 2, and down 1 and forwards 2. So there's half of my absolute value graph, and then I'm going to reflect that and do the opposite for the other slope of the other side of this graph. So down 1 and backwards 2, down 1 and backwards 2, down 1 and backwards 2, and so on. And there's my absolute value graph, and I can see that it fits the description we said. It has been compressed or opening wider, if you want to think of it that way. The graph does open downwards because we have a negative negative a value, and then we've moved the vertex and all the points right 3 and up 2.